Testing sound. Testing. Testing sound. Okay, we'll start. Good evening. Can you confirm the sound and the video? Good evening. Right. It's fine for me. Can anyone confirm whether it's clearly audible and visible? Yes, okay. All right. Only two more to come. Right. Okay. Good evening. Since others are still joining, what you can do is, if you haven't downloaded the study material yet, I have pinned a message in the chat, right? So you can go there and download it and be ready. I will start in 5 minutes. We will start in 5 minutes. So get ready. Prepare yourself and get ready. I will start in 2 minutes. Okay, we'll start. Right, we'll start. Right. Good evening again. And yeah, we'll start. About today's session, since we have kind of a lot to do, I have planned a lot to do, right? My plan is to finish this off by 10:30, and for that I need your full support, because I have planned something kind of more than 3.5 hours, but have to complete during 3.5 hours, right? Here I think I have put around 44 graphs or something like that. Yeah, there are 44 graphs here to practice, right? So before practicing those graphs, first we have to finish off the techniques and the theory part here, right? So first we'll go through that and get into the questions. Questions in the sense, there are some practice graphs that you can check whether you have gained this skill, you have understood what we discussed today by plotting these things, right? So mainly first part of the class will be on the theory part. Theory means the techniques we are going to use here when plotting graphs, right? There are several techniques based on different standard curves we have, right? And in addition to normal functions, I'll cover a little bit on trigonometric functions as well, right? Because we have trigonometric curves also in our syllabus, right? already you know in friction you have made it for the first time in friction for 27, right? If there's anyone who is joining from 26, you know in simple harmonic motion, throughout simple harmonic motion we have trigonometric curves, right? So likewise there are some places in magnetic fields also there are some places we have trigonometric curves as well, right? So since I need to cover it as an overall, I will touch on that as well, right? Okay, so that's the plan. Initially, in the first part, we'll quickly go through the techniques and the standard curves, right? And the other parameters that we check, that we look at in a graph. And my plan is to quickly move on to the practice questions, practice graphs, not the questions, practice graphs. Okay, right. So the first thing is, let's see what is meant by gradient of graph. And I think I have discussed about gradient and gradient types in linear motion as well, right? Same thing. But if there's anyone who is joining today just for the graphing session, I'll quickly go through that as well. Otherwise, for the theory class ones, I have discussed this gradient part, right? Just the gradient part in graph conversions, linear motion graph conversions, right? Okay, but since we need to get the start from the sketch, we'll start from there, right? Okay, and all the things we discuss here will be valid throughout physics until you are sitting for the exam. Throughout physics, in the sense, now even if you do higher maths or higher physics, also these techniques are there, but they will be kind of getting advanced when you are going to the higher side. 1 second, I don't have Telegram. Doesn't matter, click on that link, then you will be navigated there. No need to have it. Can I have link to the PDF? Yeah, no need to have it as an app. Just open it from any web browser you have. Okay, right. So we'll start from here. And when it comes to graphs, something additional. When it comes to graphs, we have graphs of different number of axes. But here in A levels, we only have 2D graphs. 2D means we'll be considering the variation of two variables at a time. Right? 3D graphs are also there, but we don't have that in A levels. Otherwise, 3D graphs exist in the world, and 4D even there. Right? Graphs ගොඩක් තියෙනවා. හැබැයි මේ A levels වල අපිට especially for physics, we only have 2D graphs. Right? Where only two variables are there at a given time. Only two. Right? When two are getting varied, all other parameters which are there in the equation will remain constant. Right? ඔක තමයි idea එක. Okay. So this will be basically on 2D graphs. Right? 2D graphs නැතුව 3D graphs කොහොමද මේ වෙනකම් ඔයගොල්ලෝ දැකලාත් නැහැ. But you will see in the future. But not here in physics. Okay. First heading, gradient of graph. Gradient. Gradient of graph. Gradient of graph. Right. Listen. As an example variation, if I plot a graph between plot a variation between y and x, right? Variation between y and x. The difference of the value along the y-axis should be delta y, no? Difference of the value along y-axis between these 2 points actually should be delta y, and difference of the values here in x-axis should be delta x, right? Gradient of graph is defined like this. Is a definition. This is a definition. Gradient, and the standard symbol of gradient is simple length. Standard symbol of gradient is simple length. Right? Gradient is defined as difference of y over difference of x. Don't say y over x. That is delta y over delta x. Right? Not y over x, because gradient is something defined for the difference of y, not for a point. Point එක gradient එක නෙමෙයි. Right? Point එකක් ගත්තා that should be having even a very tiny difference. Difference එකක් නැත්නම් gradient එක ලියන්න බෑ. So we have to have a difference. then that is not y of x as O levels, that is delta y over delta x. Now, to present this in another way, express this in another way, if I assume this angle as theta, right? You know, tan is the opposite side of adjacent side, no? Now, delta y over delta x should be opposite side of adjacent side as well. Then, this can also be written as or considered as tan theta, tan value of this angle, right? And angles are measured only in anticlockwise direction as a standard, right? That's a standard we do in physics and maths. Standard direction of measuring angles is anticlockwise. Then, with respect to this anticlockwise angle, if you write tan theta is delta y over delta x, then which means there are only two ways that you can express the gradient, right? Either as delta y over delta x or as tan theta, right? Only two. Take this down. And first idea is this, highlight this. I have touched on this thing in linear motion graph conversions. But don't worry if you are not there, today also I'll be discussing from scratch. But if you were there already, this is something you already know. What about Malin sir? I mean physical line. Right, take it down. Since you are learning all the techniques about graphing today itself, right? I won't be doing this much of a comprehensive discussion again in the class, right? Because today I'll be discussing everything. Okay. Then as a next heading, write down sign of gradient. Sign of gradient. Sign of gradient. Sign of gradient. Look at the board. As I told you, angles are measured only in this anticlockwise direction. Angles are measured only in this anticlockwise direction. Right? If this angle measured in anticlockwise direction is acute, right? The tan value is going to be tan value of an acute angle, no? Right? And if this angle is obtuse, gradient is tan theta, right? Gradient is tan theta. So tan value of an obtuse angle is coming, right? So especially if you are doing combined maths, you have some idea about how tan values are varied, right? So if not, don't worry, we'll be showing over trigonometric variations today also. Then you will see how tan values are getting varied, right? But if you are doing combined maths, already you know that tan values greater than 90 are negative, no? They are negative because it starts from 0 and tan 90 becomes infinity, and greater than 90 means they are negative, right? That is where this idea is coming. And all the tan values between 0 and 90 are positive. And tan values greater than 90, okay? Greater than 90 means actually 90 and 180. It's a 90 and 180 are negative, right? So therefore, gradient is tan theta. Then this is tan value of an obtuse angle. Acute angle. So this is tan value of tan theta, but this theta is let me write this way, acute. When this theta is acute, right? So you are writing tan theta, and tan theta of an acute angle is plus, right? So does gradient becomes plus because gradient equals tan theta. Now tan theta is plus, so this gradient is plus, right? And here, if this was obtuse, then tan theta becomes negative. When tan theta becomes negative, gradient becomes negative because gradient equals tan theta, and gradient becomes negative. So simply the idea we have to have from here is, right, gradient of any acute angle with horizontal is positive, right, and gradient of any obtuse angle with horizontal is negative, right? Okay, take it down. Okay, right? Right. Then, so based on this, we have different types of gradients in graphs, right? So up to that point, I have discussed in linear motion, right? So let's recall what we have done there. Write down types of gradients. Next heading, types of gradients. Types of gradients. Right? Now keep this idea in mind when moving forward, because based on this, we are going to identify these types of gradients. Types of gradients. See? Okay. If you need to identify a gradient, right? We know gradient equals tan theta or delta y or delta x, right? Then you can use anything when identifying a gradient. But using tan theta is kind of easier because we know something about tan values of obtuse and acute angles, no? Right? Okay. See, now say I need to identify this gradient. So before that, let's go to this one. Second one, see. Now this is the second curve I have given. We know if I need to check the gradient is given by tan theta. Gradient is given by tan theta, right? Then check this angle of the curve given, right? Straight lines are also called curves. Curves it's not the literal curve. Curve tamai, right? The reason to say it is straight lines are curves. That's also called curves. Curves a general term. Curves curve, right? All of them are curves. Right. Now if you check these angles, this angle is same throughout the straight line, right? If the angle is same, angle is constant. If the angle is constant, tan value of this angle is constant. And if you check whether it's acute or obtuse, that is an acute angle, right? Since that is acute, the gradient should be plus. Since this is acute, gradient should be plus. And since this angle is constant, angle is a constant now, then tan value is constant, which means gradient is constant. So this is called a positive constant gradient. That is called a positive constant gradient. Something like this, right? And if I do the same for the first one now, see what happens? Check. This is the logic behind this, right? Now after this thing, you have to memorize this. When we do conversions and plotting graphs and everything. For everything, you have to memorize this, but know the concept, know the logic, right? This is not something to parrot, right? You have to memorize, but don't parrot. There's a clear logic behind this. Logic. Now, if you check this angle, again, moving from here to here of the curve, see what's happening with this angle? First, tell me whether it's acute or obtuse. Acute. What's happening with the angle? Increases, right? Increases. Then since it is acute, gradient is plus. Since it is acute, gradient is plus. But theta increases. See, theta increases now. When theta increases between 0 and 90, tan theta increases. Since tan theta increases, this gradient increases. So that's called a positively increasing gradient, right? Likewise, we can argue on all these shapes, all these types of gradients given, and we can check which types of gradients they have, right? Now there are different types of gradients, right? 1, 2, 3, 4, 5, 6, 7, 8, right? In any graph that you see, if you are plotting a 2D graphs, there are only 8 gradient types, right? All 8 are here, right? That's why I mentioned everything on this single graph for you to see the differences as a comparison and to compare and contrast between everything, right? So likewise, we can do the same for all the things, right? Now, I'm not going to explain each and every one like this, right? You can check the angle and have to collate this with what we are doing in trigonometric variations. Again, variations link right? Now, even though I discuss the variation types of gradients here, right? When we do the variation of tan theta, right? When you do the variation of tan theta, in friction I have already done same thing, right? But if there's anyone who don't know the variation of tan theta, once I discuss about the variation of tan theta, you will understand this better, and you should be able to link that to that variation from here, right? Tan theta anything, tan theta gradient right? That's the thing. Okay, now this is a positively increasing gradient, and this is positive constant gradient, and this is positively decreasing gradient. If you check this angle decreases, right? But yet that is acute, so positive and decreasing. And these shapes are, see, angles are obtuse, no? Angles are obtuse. Angle is always measured from horizontal to the curve in anti-clockwise direction, right? Then all these angles are obtuse. So they are negative gradients. See, they are negative gradients. And this is a negatively increasing gradient, because when what happens to the angle from here to here? What happens when we are moving down? What happens to this angle? Angle decreases. Angle decreases. So this is a negative value. This is a negative value, right? And when this angle decreases, this value as a negative value, this value increases, right? So overall value increase. That's why it's called a negatively increasing gradient. And if you are not aware about the variation of tan beyond 90, right? Just be patient for another 10-15 minutes. You will see the trigonometric variations in the next part, and there you will see the variation beyond 90. अन्य variation का आवड़ वासे मम्मे का ही explain करना. हाँ, एक इतने तो link है. Negative increasing, negative constant, negatively decreasing, and this is a horizontal curve. In this horizontal curve, angle is horizontal is 0. Then it goes to tan 0. Tan 0 is 0. Right? And this one, it goes to tan 90. Tan 90 is infinity. Right? So these are the all gradient types we have. Right? Take it down. And this is how I argued. If you have no idea about the obtuse angles or obtuse values of tan, be patient for like 15-20 more minutes, then we'll see. This is the concept behind this. This is the concept that you need to understand. This is the concept behind this. Right? Now, after today, you have to memorize this, but know the concept. Everything has a logic and a justification behind. So, justification is here. Right? Negative constant. Sorry. Maru. Negative constant. Sorry. Yeah, likewise, be vigilant when you are in the class. So, Sustan positive. Yeah, that's negative constant. Sorry. Okay, finish. So today we have a lot to do, and I need your full support when proceeding. Okay, right. Let's move on. And hereafter you should be able to memorize these types of gradients, right? And we already know these things from linear motion graphs. Okay, now let's move on to the standard curves we have, right? As I didn't write down standard variations. Standard variations. Standard variations. Right. I will break down all standard variations into 5 categories, and we are going to go through one by one. Right, first main category is linear curves. Linear variations, or say linear functions. Right, and this is how a linear function is mentioned: y equals x to the power n, where n equals 1. Such a function is called a linear function, right? Which means power of independent variable should be 1, right? X is called the independent variable and y is called the dependent variable, right? And x is what we are practically changing in a graph, right, in a variation, and y is the one who depends on x, right? When x changes, only y changes, right? So therefore, this is called the independent variable. If there's anyone who don't know these ones, additional, x is called independent variable, and y is called dependent variable, right? And first type, see. So I'm pretty sure that you know all these types of curves from all of us, all linear ones you know, right? Now we are going to collect everything to one place here and going to start. See, y and x. Any curve which has the index of x, so power of x as 1 is a linear curve, no? Right? It's a linear curve. And if it goes through, and by the way, what is intercept? What is intercept? What is intercept? Intercept is the point where y-axis is intersected, right? When x becomes 0, right? Okay, idea, right? See, now first one is about linear curves, and these are the standard linear curves we have. Standard ones, standard linear curves we have. If it goes through the origin, that is in the form of y equals mx, and we know m is gradient, and if you check the gradient here, gradient is positive, right? So it's a positive gradient, y equals mx. When x becomes 0, y becomes 0. So it goes through origin, right? And if gradient becomes negative, it is y equals minus mx. Gradient is negative because it's making an obtuse angle, right? But still, when x becomes 0, y becomes 0, it goes through center, origin, right? Center means origin. And if an intercept comes, this is how it is getting different, right? This is y equals, still gradient is positive, angle is acute, plus c, if it intercepts at c, right, plus c. And if it intercepts at somewhere here, this is called, still gradient is positive because angle is acute, mx minus c, right? And this type of a curve that's also going through same c, then y equals, angle is obtuse minus mx plus, but y is intersected at plus c, so that is plus c. And this one, y equals minus mx minus c, right? And simply, I have mentioned all linear variations we have as standard curves here, right? When gradient changes, the direction of the graph changes, and when intercept changes, the point where it is intersected at y-axis changes, right? Take it down. If there's anyone who have no idea about what intercept is the point where y-axis is intersected when x becomes 0. Right? If anyone needs intercept, right? Standard notation of intercept is c. Right? So this is plus c and this is minus c. Plus c and minus c. Standard notation of intercept is c. Intercept is the point where y-axis is intersected by the graph, by the curve, when x becomes 0. Right? You can mention it if you don't know. Right? If you are using different colors for your clarity and understanding, you may use them, right? That's up to you. But if you are using different colors, it's up to you. Because at the end of the day, this should be 100% clear to you because you are the one who is going to refer this again. Right? And always be vigilant, understand the concepts and take it down. Right? Understanding concept and the logics here is the key when you are plotting graphs. That's the key here. Don't just take down what I do here on the board, right? Understand it. And if you didn't get anything, feel free to ask. How is the quality of red when I write using red? Right. Okay, let's move on. Number 2, nonlinear curves. Nonlinear curves, nonlinear functions. Nonlinear curves means nonlinear functions. Nonlinear functions. Right? We have 3 types of nonlinear functions, right? So let's go one by one. First one, y equals xn, where n is greater than 1. Where n is greater than 1. Right? Write down. Nonlinear functions y equals xn where n is greater than 1. Okay, now from these nonlinear variations also, you can connect what we do here with what you know already from O levels, because you are plotting quadratic variations in O levels, right? Variations in the form of ax squared plus bx plus c equals 0, right? So that is about power 2, and what we are doing here is for any power which is greater than 1, but it should be aligning with what you already know with quadratic variations, right? So it will be aligned. Okay, let's see. First tell me, now let's get a quadratic equation as an example. If I have an equation like y equals mx squared, right? Y equals mx squared. So what happens when it is mx squared and what happens when it is minus mx squared? That is something you are touching in all levels. We call minimas and maximas. So if there is mx squared, is it a minima or a maxima? Mx squared, y equals mx squared. It's a minimum, right? And if there is minus mx squared, it's a maximum, right? If needed, you can check this with values as well, right? Now, this kind of a curve is y equals, now as an example, I will take quadratic ones and all these variations are valid for any index here greater than 1, right? Even if you draw mx cube, same shape comes, right? For mx to the power 4 also same shape comes, right? Mx squared. Now, if you need to get an idea about this, right, what you can do is apply a value for x and check how y is varying. Now, as an example, say when x becomes 1, or 0 when x is 0, y is 0. So it is going through origin. And say x is 1, when x is 1, this is m into 1 squared means m. And when x is minus 1 also, you are getting same answer. Because the square value of minus 1 is also 1. Which means for a given x value, right? For a given x value, sorry, for a given y value, there should be 2 x values, right? For a given y value, like this, there are 2 possible x values. That's how it varies, right? Now, since this is like looking complex, I'll erase these things, but just know how these things are checked. This is how it's checked. Okay, now if I draw minus mx squared, this is how it comes. Y equals minus mx squared. And for these curves also, if it is intersecting the y-axis, right, it has intercepts, right? This is how it varies if it has an intercept. So this is plus c, and this is y equals same shape mx squared plus c. When x becomes 0, y equals c. When x becomes 0, y equals c, right? And if I draw minus mx, mx squared minus c, minus mx minus c, it is something intersecting the y-axis here, minus c. So it is like y equals mx squared minus c, And if we draw something like this, this is y equals minus mx squared now, that's a maxima, but intercept as at plus c, minus mx squared plus c. And this one, y equals minus mx squared minus c, right? So these are the basic shapes of all curves which are in this category here. And when we are moving forward for physics, basically what we need is the variation between 0 and 90, right? This is called the first quadrant, right? We need the variation of the first quadrant. But when I draw the variation of the first quadrant, you can't see the exact shape of the graph. That's why I draw the exact shape, right? And make a minima එකක් කියලා පේන්නේ නැහැ නේ මම මේ පාර්ට් එක විතරක් ඇඳුවා. හැබැයි ඇත්තටම අපිට ෆිසිකල් ඕන වෙන්නේ මේ ෆස්ට් ක්වාඩ්‍රන්ට් එක විතරයි. ෆස්ට් ක්වාඩ්‍රන්ට් එක කියලා කියන්නේ මේකට. between 0 and 90. ඔක තමයි ඕන වෙන්නේ. but shape එක හරියට දැනගෙන ඉන්න ඕනේ. නැත්තම් මේ curve එක විතරක් ඇඳලා මේක මොකද්ද curve එක කියලා පේන්නේ නැති හින්දා තමයි ඔක්කොම ටික ඇඳලා තියෙන්නේ. Right? But when moving forward, when you practice these graphs, right? We'll practice only for the first quadrant. Right? Take it down. It will be around 10:30 when we finish. 10:30 කිව්වා. ඒක මම ආයෙත් කලින් කිව්වා මට දැන් මතක් වුණේ. මේ ඕන කොල්ලද? ආවිල්ලා බලائیں. And I have a workload of like 4.5 hours and try to complete within 3.5 hours. That's the thing. I මදි වුණොත් පොඩ ස්පීඩ් කරන්න ඕනේ ඒක. Don't worry, I won't be rushing through, but පොඩ්ඩක් speed down. Right. Finish. Next one. Another. Right. Next type. Right. Still we are under nonlinear curves. Problem number two, y equals xn, where n is between 0 and 1. What's the meaning? When x is between 0 and 1, which means that's a power between 0 and 1. Powers between 0 and 1 means, what are the examples? Powers between 0 and 1. Power of half, square roots, or any other power. And most common power you know and we use is square roots. So this is valid for any value in that range. Okay, see. Right, see. Now, as an example curve, I'm going to take this one. Look at the board. Y equals m root x as an example curve. It matches this, no? Right? Power is half now. M root x, root means half, no? So this is like mx half. Power is half. So as an example curve, I'll be taking m root x, right? M root x. Now, if you need to get an idea about the variation, how variation goes, right? We know we can do anything for both sides of the equation, no? The standard curve is m root x. If you square both sides, it gives y squared equals m squared x, no? Now, what's happening is, for a given value of x, there are two values of y. Opposite of this, compare with this one. Now here in mx squared, for a given value of y, we had two x values. That's x squared variation. Right? For a given value of y, we had two x values. Now this is x equals y squared. Then for a given value of x, there are two y values. Got it? Then, since there are two y values, this is how the graph is going to be. For a given x value, there are two y values. Got it? My graphs in. Now all these graphs are symmetric across x-axis, and all these graphs are symmetric across y-axis. Okay, this is how it comes. See? Now, this one is the example curve I'm going to consider. So this is y equals m root x. Y equals m root x. As an example, if you put 4 as x, square root of 4 is plus or minus 2. Right? 2 නෙමෙයි පොඩි කාලේ වගේ අර පොඩි කාලේ තමයි 2 දැන් plus or minus 2 නේ. Right? Square root of 4 is plus or minus 2. එහෙනම් මෙතන දැන් මේක 4 වෙද්දි මේ +2 වලත් මෙයාට පොයින්ට් එකක් එන්න ඕනේ -2 වලත් පොයින්ට් එකක් එන්න. මොන ඔක තමයි මේක අයිඩියා එක. හරි. Likewise, there are two possible y values for a given x value. මෙහෙමයි curve එක එන්නේ. And if it is y equals minus m root x, this is how it behaves. Right? And this curve is going to intercept the x-axis like this. Right? So that is called the x-intercept. Right? By default, intercept is the intercept of y. එතකොට අපි intercept of y කියලා කියන්නේ y intercept කියලා කියන්නේ because that's a default scenario. හැබැයි x එක නම් intercept කරන්න යන්නේ. Right? Specifically we say x intercept. Right? මෙහෙම එකක් වුණොත් right? මෙහෙම curves තියෙනවා. They are like y equals m root x plus c, something like this. Plus c, something like this. Right? මේක ඔන්න x එක 0 කරලා බලන්න පුළුවන්. When x becomes 0, there's an non-zero value here. There's an non-zero value here at plus side. ඔක තමයි වෙලා තියෙන්නේ. හරිනේ? There's a non-zero value here at plus side. And මෙහෙම දෙන්නත් පුළුවන්. Right? And මේ දෙක දෙන්නත් පුළුවන්. Minus m root x minus c, and මේක දෙන්නත් පුළුවන්. Minus m root x plus c, and all these curves are not going to work for all x values, right? එහෙම වෙන්නේ නැති curves තියෙනවා. Get the idea about the shape of the curve, right? Otherwise, especially if you are doing maths, if you think a little bit further, right, you will see some values of x which are not matching with these variations. Yes, such values exist. But I draw the variation because we are going to move ahead only with the first quadrant, but you have to know the shape. That's why. Right? Any values make it, take it down. Be quick. When you plot them, these curves can intersect each other. එහෙම වුණා කියලා ප්‍රශ්නයක් නැහැ. මේ curves ආ ඉස්සරහට යනකොට මේවා intersect වෙනවා. Right? මේක intersect වෙනවා. එහෙම එකක් නැහැ. ඒවා intersect වෙයි. That's fine. Finished? Right. From number 3. Number 3 of nonlinear curves. Y equals xn, where n is less than 0. Where n is less than 0. Where n is less than 0. Right. N is less than 0 means negative indices, negative powers, right? Negative powers. As an example curve, right? I'm going to consider this one. Y equals mx to the power minus 1, right? This can be written as m 1 over x, no? Right? As an example curve, I'll be choosing this, right? Y equals m minus 1, that is 1 over x. 1 over x. See? Y and x, right? Now, about this curve, there's something we should see first. Look at the board. Y equals m 1 over x, right? If I need to check the y-intercept, right? Y-intercept, we have to make x 0, right? We have to make x 0. See what happens when x is 0? When x equals 0, y equals m 1 over 0, right? What is 1 over 0? What's the value of 1 over 0? Infinity. 1 over 0 is infinity. 1 over 0 is defined as infinity, right? 1 over 0 is defined as infinity, which means y goes up to infinity when x becomes 0. Y goes up to infinity when x becomes 0. Y goes up to infinity when x becomes 0, right? And if you check x-intercept, let me do it here. Y equals m 1 over x. To check x, subject x, so x is given by m 1 over y. No? To check x-intercept, it should be when y equals 0. When y equals 0, same thing happens. X is m 1 over 0, and this is again infinity. So x is also going up to infinity. X is also going up to infinity, right? Which means when x becomes 0, y becomes infinity, and when y becomes 0, x becomes infinity. When we plot graphs, listen, when we plot graphs, if we get infinite values like this, right, it is not possible to plot infinity, you know? Then we use a small strategy, a trick. What is it? Asymptotes. Right. So what we are doing is, if you need to show that it is reaching infinity, what we are doing is, we are plotting the line parallel with the axis at the last part. If we plot it parallel without showing any intercept, right, which means that graph goes up to infinity, right? Now, this is how we plot this. Make a touch in the back, if you draw this part parallel to the axis, right, it shows that's a strategy, that's a technique, a tool we use, technique we use to show infinity, because otherwise there's no any method to, there's no any possible way to, practical way to show infinity in the graph. No? Infinity එක આવොත් අපි කරන්නේ parallel axis එකක් අදිනවා without intersecting. මේ තියෙන මේ point එක දැන් when x becomes 0, y goes up to infinity, right? When y becomes 0, x goes up to infinity. Got it? So this is the standard variation of, right? This is standard variation of y equals m1 over x, m1 over x. And in these curves, since y and x are at numerator and denominator, they are also called inverse curves, right? ඒකත් mention කරලා තියෙනවා. They are also called inverse curves, inverse functions. They are also called inverse functions. right? Inverse in the sense y and x should be like up and down, right? මෙයා ඉන්නේ numerator එක නම් මෙයා ඉන්නේ denominator එක. Or these two can be switched as well. Right? කොහොම හරි දෙකක ඉන්න ඕනේ. They are called inverse functions. They have inverse relationships because when x increases, inverse කියන්නේ මේකනේ. When x increases, y decreases. Right? When x decreases, y increases. Right? ඒ variation එක දැන් මේකේ තියෙනවා. When x increases, the value of y decreases. Right? And the beauty of this curve is, right? The beauty of this curve is, now if you apply a negative value here, what happens? If you apply -1, then there's a minus value for y now. If you apply -2, again there are values, which means this is not the complete curve yet. This is only the curve which is on the positive axis, positive side. Make a minus side there. But you don't see this consistency of the curve because it is coming from infinity. This is the same curve. Huh? It's not two different curves. This is the same curve. What happens is this curve reaches plus infinity from here, and again it disappears from plus infinity and appears from minus infinity. Right? And this curve disappears from plus infinity and appears again from minus infinity. Right? That is how this panel is connected. Right? Once you do differentiation, right, in grade 13 differentiation differentiation and if you have plot curves using differentiation, you will get to know about this idea in a very depth. Right? Physics surface because this is what you need to know. Plus infinity minus infinity right? එහෙම වෙනවා. ඒ කියන්නේ දැන් මේක එන්ඩ් එකක් නැහැනේ. ප්ලස් ඉන්ෆිනිටි එකෙන් ඉවර වෙන කර්ව් එකක් අනිත් පැත්තේ මයිනස් ඉන්ෆිනිටි වලින් එන්න පුළුවන්. ඒක ලිමිට්ස් වලින් තමයි එක්ස්ප්ලেইন කරන්න. ඉතින් ලිමිට්ස් හදුවා ඒක ෆිසික්ස් වලින් එක්ස්ප්ලেইন කරන්න බෑ. there are something called limits, right? ලිමිට්ස් වලින් තමයි ඒක එක්ස්ප්ලেইন කරන්නේ. just know that this is the same curve. ඒක verify කරගන්න තියෙන විදිය තමයි plug some values and see. හරි? මේකට values දාලා බලන්න. If you apply 1, this becomes positive. 1 2 3 4 5 වගේ values වලට මේක මේ පැත්තේ තියෙන්නේ. For the values of x like -1, -2, -3, -4, the curve is here. So that's the same curve. Curves දෙකක් නෙමෙයි. That's the same curve. Same curve. මේ තියෙන්නේ same curve. Y equals m1 of x. Right? ඊට පස්සේ මෙහෙම දෙන්නත් පුළුවන්. Right, this is like y equals -m1 of x. Y equals -m1 of x. Right? Now, if you draw even 1 over x squared, x cubed, anything, right, which satisfies this, same shape comes. Right? Okay, take it down. This is called an asymptote in maths, right? If you don't know this word. Asymptote. Right, that is called an asymptote in maths. So what we are doing is, that's a small trick we have. If values are reaching infinity, right, what we do is we are plotting it parallel to show that it is reaching infinity. To show that it is reaching infinity. Why 1 over? Because 1 over 0 is infinity. 1 over 0 is infinity. right? You have to know these things. 0, 1. I'll tell you 0, 1. 0, 1. 0. 0, 1 is 0. 1 over 0 is infinity. And 1 over infinity? 0. Usually we don't write equal signs with infinity because we have nothing defined as infinity now. There is some kind of an hypothetical scenario. Infinity කියලා එකක් තියෙනවා. හැබැයි infinity කියන value එක මට කියන්න බෑනේ whether it's 1 billion or 10 billion or 100 billion එහෙම කියන්න බෑනේ. Right? ඒ හින්දා අපි ඒකට කියන්නේ reaching infinity කියලා. Reaching infinity. Right? මේ simple simplifications මේවා දැනගෙන ඉන්න ඕනේ. If you don't know, mention them. One over 0 කියන්නේ infinity වෙන්නේ ඇයි කියලා තේරුම් නැත්නම් කියන්නම්. But within the frame that you will understand. හොඳටම explain කරන්න limits ඕනේ. Limits ගැන කියලා වැඩක් නැහැ. නිකන් තේරෙන විදිහට ඕනනම් කියන්න. You need to know how 1 over 0 becomes infinity. 1 over 0 becomes infinity වෙන්නේ මෙහෙමයි. See? ඔතන issue එක තියෙන්නේ ඉතින් ඕක O levels වල කියන්න නැති හින්දා. O levels වල ඕක not defined හරි මොකක් කරේ නේද කියන්නේ? Not defined. එහෙම කියනවා? Not defined කියලා කියනවා නේද? It is actually not defined තමයි, but it's reaching zero, reaching infinity. ඒක තමයි not defined කියලා O levels වල කියන්නේ. Right? මේවයි වෙන්නේ. Look at here. Say I have a number as 101. 101. What's the value? 1. And if I reduce this denominator, 0.1, what's the value now? 1 over 0.1, 10. Then 1 over 0.01 is 100. 1 over 0.001 is 1000. 1 over 0.0001 is 10,000. Now, when this minimizes, this maximizes. See the pattern. When this minimizes, this maximizes. Then, if this is minimized to the minimum possible value, 0. If this is minimized to the minimum possible, this should reach the maximum possible. Maximum possible value we have in our number system is infinity, right? Then theoretically, it is reaching infinity, right? That's why we say 1 over 0 is infinity, right? It's logical and it's 100% correct. Because infinity is hypothetical. Infinity is hypothetical. If this reduces to 0.000001, make increase, there's no limit. Then when this is at the minimum possible value, this is at the maximum possible, that is infinity. Right? Otherwise, okay, on the definitions here now when you are learning limits in combined maths. Right? When denominator decreases, the value increases. When it is minimum possible, this should be the maximum possible, infinity. Right? Okay, I hope it's clear now. Right? මේක ඉතින් O levels වල කියන්න නැතුව ඉතින් not defined හරි මොකක් කරේ කියනවා. ඒකයි ඔය case එක. Right? Then not defined නෙමෙයි. Okay. Let's move on. Then before moving on to trigonometric variations, let's have a summary here of what we discussed so far. Right? Summary එකක් කියලා කියන්නේ අපිට ඇත්තටම first quadrant එක නෝන වෙන්නේ. ඔන්න ඒකේ පොඩි summary එකක් අපි බලමු මොකද වෙන්නේ කියලා. See? Summary. Okay. See? About about these variations if I plot on the same panel, fine. If I plot on the same panel about these variations, see what happens. මම අදින්නේ first quadrant එකේ තියෙන non-linear where index is greater than 1, right? Okay. See, මෙමයි වෙන්නේ. Say this is y equals mx squared, right? And this is y equals mx cube, and this is y equals mx to the power 4, right? What is this common point? What is this common point? It has mx on it. Y equals x squared, x cubed, and x to the power 4, right? Now m is 1 now. M is 1, right? M is 1. Okay, what's the common value? It is intersected. What's it? What value? May common value what's it? It's 1. Square of 1 is also 1. Cube of 1 is also 1. Fourth power is also 1. Any power of 1 is 1, right? When x equals 1, this becomes 1. 1 can value make intersect. And for values which are less than 1, make a special. For values which are less than 1, if you square it, the value becomes even smaller. Is it clear? See? Now, say when x equals half, x squared becomes 1 over 4. Value becomes even smaller. But for positive values like x equals 2, x squared is 4. It increases, right? So that's why when this power increases, for the values which are less than 1, this curve goes below this one. If needed, you can use 3 different colors and plot, right? Black man in the video. See? X squared for x cube, it goes below x squared, below 1. Hey, I make cube 108, right? But for values which are greater than 1, value rapidly increases. For values which are less than 1, value rapidly decreases, right? So variation. Take it down. In nonlinear functions, gradient is changing. Gradient is constant if and only if that's a straight line. Go back to types of gradients and cross check. For all nonlinear functions, gradients are constant. Gradients are changing. Right? So it's changing according to gradient types we discuss. Then the next set. Same thing happens with these set of graphs as well. Maybe in the power half, no? When power decreases, it comes down, but before 1, below 1, right? The opposite occurs. Take it down. And about inverse curves, this is how they behave. About inverse curves. Inverse curves are the easiest type and the easiest shape that we can draw, right? If there is inverse, always this variation comes, and this is also called inverse variation. This is also called inverse variation because of that inverse property. Inverse variations. Right? And finally, if I plot all these main curves together, see, if I plot all these main curves together, like y equals x, right? And y equals x squared, and y equals root x, and 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 y equals 1 over x. This is how they are on the same plane. Still, all of them intersect at 1. 1 දැම්මොත් මේ ඔක්කොම answer එකනේ 1 නේ. Write it down. So here in the summary, what I have mentioned is variations of our main curves in first quadrant. Right? This is what we will need for proceedings. Finished? Okay, any questions so far? Now, next thing we have to, next and the final topic we have to discuss is trigonometric variations. Before trigonometric variations, any questions so far? All good? Good anyone? What about you? All good? Ask if anything before moving on. Okay, right. Then let's move on. Main number 3, trigonometric functions. Main number 3, trigonometric functions. Main number 3, right? Numbers only have linear functions, non-linear functions, and the third one, trigonometric functions. Third one, trigonometric functions. Trigonometric functions. Under that, from now on, sine function. Sine function. Y equals sine theta. Right. To you to see all these values, I will draw this up to some extent, right? But for us, for physics, we only need the variation between 0 and 90, right? But to see the sinusoidal shape, I will draw this up to some extent, and it behaves for both sides, right? And this is our interested region here in physics, right? 0 to pi over 2, pi over 2 means 90, right? And this is actually 180. This is how this goes. 3 pi over 2 and 2 pi. This is how this goes, right? For this side also, this is how it goes, right? Minus pi over 2. And this is the only region that we will need for physics, right? And maximum value of sine theta is +1, minimum value is -1. Then this is at +1, this is at -1. Now you can relate this with known values to you already. As an example, sine 0 is known. In projectile motion, we have discussed sine 0 is 0, right? So that is here, sine 0 is 0. If you apply 0 here, it becomes sine 0 is 0, right? And sine 30, somewhere here, no? Sine 30 is half, plus 0.5, somewhere here. If you apply 60, sine 60 is root 3 over 2. Root 3 over 2 is around 0.8, somewhere here, 0.7 ganak again, right? Then if you apply sine 90 is 1. When sine 90 is 1. So likewise, about this region, you can cross-check with the values you know already, right? Take of sine variation, sine function. It's a sinusoidal function. This shape is also called sinusoidal. Sinusoidal. Then cos function. Second one. Let me draw it here. You can easily compare cos function. Y equals cos theta. Y equals cos theta. Right. So basically, it also has the same shape, right? It's like shape is exactly like the sine curve, but 90 degrees shifted. 90 degrees shifted. So this is y with theta 0 and cos 90 3 pi over 2 270 and 2 pi, right? And minus 90. This is also varying between +1 and -1. Both curves are sinusoidal. That shape is called sinusoidal. Sinusoidal. Right? Non-value check करा. What's the value of cos 0? Cos 0 is plus 1. Cos 0 is 1. Right? Then cos 30, root 3 over 2 somewhere here. Cos 60, half somewhere here. Cos 90, 0. Right? Then me part එක තමයි ඉතින් අපිට ඕන වෙන්නේ. Between 0 and 90. And you have got this experience already in friction, right? When plotting the variation of frictional force with angle of inclination, right? මේක තමයි use කරේ. Same thing. Okay, next one, tan function. Y equals tan theta. Y equals tan theta. Tan functions. Behavior of tan is very much different from the other two, right? From the other two, right? What's the value of tan 0? Tan 0 is 0. Tan 90? Infinity, right? Tan 90 is infinity. So it's starting from 0 and reaching infinity. If it is reaching infinity, again we have to use an asymptote to show that it is reaching infinity. Then from this side it is reaching infinity, and from this side also it's reaching minus infinity, right? And this is 90, this point up. This is 90 and this is minus 90, right? So still we need the variation between 0 and 90 to you to see the correct shape. I'm plotting this. This is how the tan variation is. Is it three different curves or the same curve? Still the same curve. When this disappears from plus infinity, it appears again from minus infinity. So likewise, it continues. Right? Take down. Tan variation. Now you can link this with link this with what? Gradients. Right? Gradient link for obtuse angles. Okay, after this thing, all the techniques can theory parts. All the theory parts that we need to discuss is over after this. Right. If you link this with gradient, remember, gradient was tan theta, no? Gradient was tan theta. Gradient was tan theta. For acute angles, acute are between 0 and 1, no? 0 and 90, no? Acute are between 0 and 90, no? 0 and 90. Between 0 and 90, when angle increases, tan value increases. Right? So that's why we had positively increasing gradients like this, because when angle increases, tan value increases. When angle increases, tan value increases. And explanation for this type of a gradient, right? Explanation for this kind of a gradient. Define as a negatively increasing one. See what happens. For obtuse angles, right? When the value increases, when the angle increases, the curve is coming from infinity to here. Then actual value increases, no? Minus 3 value, so actual value increases. And it's still negative, but the negativity negativity කියලා negativity නෙමෙයි the absolute value increases වැඩේ තේරෙනවද ඒ කියන්නේ if it is coming from -5 to -4 to -3 to -1 to අන්න එහෙම එනවනම් අන්න ඒ value එක increase වෙනවනේ ඒක තමයි මේ තියෙන්නේ negativity increases මෙන්න මෙතන ඉඳන් තමයි මේ curve එක එන්නේ correct ඒකයි මේක negatively increasing උනේ හරිනේ okay right දෙපැත්තටම ආගිය ගන්නත් පුළුවන් මේ පැත්තෙන් ඉඳන් මේ පැත්තට ආගිය ගන්නත් පුළුවන් මේ පැත්තෙන් ඉඳන් මේ පැත්තට ආගිය ගන්නත් පුළුවන් හරි එතකොට ඒකට හරියන්නේ angle එක variation එක බලන්න එහෙම දෙපැත්තටම ආගිය ගන්න පුළුවන් and this is totally depending on this because these are and variation right අර තිබ්බ types ඔක්කොම මෙතනට දැන් link කරන්න පුළුවන් okay something additional මේක ඕනම් පොඩි note එකක් දාගන්න this links with gradients මේ තියෙන gradient එක right this links with gradients gradient shapes ටික ආවේ මෙන්න මේ variations දෙකත් එක්ක I considered the variation from 0 to 90 and 90 to 180 right acute and obtuse නේ අපි බැලුවේ අන්න ඒක තමයි check කරේ okay let's move on where is the obtuse angle any angle which is beyond this point beyond 90 how obtuse right variations දැකලා බය වෙන්න එපා we need the variation between 0 and 90 right and other than that types of gradients right දැන් මේක variation එක ගොඩාක් දුරට තියෙනවා කියලා ඒකට බය වෙන්න එපා එහෙම තමයි ඉතින් variation එක there's no limit for the variation මේ 90 මේ තියෙන 180 there's no limit for the variation right let's move on any questions up to here any questions online quickly any questions 8:40 and you should be able to memorize these things in first quadrant means between 0 and 90 hereafter right ඔක තමයි දැන් අපිට ඉස්සරහ වැඩ වලට ඕන වෙන්නේ හැබැයි 0 and 90 විතරක් මේක ඇඳ කියලා මේ variation එක පේන්නේ නැති ඉඳන් ඉතින් එහෙම ඇඳලා දැන් මේ part එක විතරක් ඇඳනනම් මේක sinusoidal කියලා පේන්නේ නැහැ නිකන් මේ චුට්ටක් ඇඳලා right මේකත් එහෙමයි so that's why the entire variation is drawn but we will need the variations in first quadrant between 0 and 90 for our proceedings okay now let's see how this knowledge is used to plot a given graph see okay I will give you 3 minutes quickly go through what we have done from the beginning because now specifically and especially you should be able to memorize the variations between 0 and 90 right right quickly go through what we have done today from the beginning and you can refresh yourself if needed. මෙතනින් පස්සේ graphs අඳින්න තමයි තියෙන්නේ. theory නෑ. I will explain using few graphs now, and in the tut I have put like 44 graphs. ඒ 44 නම් ගෙදරයි. එහෙම එකක් තියෙනවා. And ask if anything. Ask if anything. And this knowledge that you are gaining today is something to be used until you are studying for the exam, right? Or even after that, right? ඊට පස්සේ වුණත් මේවා ඉතින් ඔක්කොම valid. Right. Okay, finish. Okay. So as a heading, write down plotting graphs for a given scenario. 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 Okay, look at the board. First, if I explain the gravity here of graphs, right? Now, this is how plotting graphs is going to be used in our paper, right? This is how it is going to be used in our paper, right? In paper 1, right? In paper 1, out of 50 MCQs, right? Usually around 10 graphs are coming. Usually around 10 graphs are coming. Around 10, right? Usually around 10 graphs are coming. Right, around 10 graphs, which means 10 graphs are coming, which means it carries 10 marks here, right? It carries 10 marks here. And from paper 2, part A, in structured essays, right? Usually any structured essay has a graph, right? Usually, right? From our 42 experiments we have, right? There are like 4 experiments without graphs, right? අනිත් ඔක්කොම graphs තියෙනවා. මෙතන එන 4ම graphs එනවා ගොඩක් වෙලාවට. Then here you will get 4 graphs, right? You will get 4 graphs in 4 experiment questions, 4 structured essays, right? And other than that, in part B, right? Again, graphs are coming. You have got variations, right? Now, as a total, if I collect everything here, right? It is coming to around 5 marks, right? It is coming to around 5 marks as a total, right? Out of 100, out of 100 then altogether, this carries around 15% of marks in our overall paper, like 15% of marks from our overall paper, right? 15 කියලා කියන්නේ ඉතින් එක ලොකු amount එකක්. 15% out of final 100, right? So therefore, having this skill of plotting graphs is compulsory when you are going to the exam. Graphs අඳින්න බැරුව exam එකට ගිහින් වැඩක් නැහැ. හරි? එරින්ම නිකන් 85 වලින් ලකුණු ගන්න ගියා වගේ වැඩක් වෙන්නේ. graphs අදින්න නැහැ කියන අනිත් ඒවා ගොඩක් වෙලාවට ඒ වගේ කෙනෙක් කරන්නේ නැහැ. ඒකට ඉතින් 85 නෙමෙයි. මොකද graphing කියලා කියන්නේ that's a much needed skill and must have skill when you are going to the exam and when you are learning physics, right? දැන් තමයි questions කරලා දැකලා තියෙන graphs කොච්චර එනවද කියලා, right? friction, rotational motion, center of gravity ඔය ඕන එකකට graphs link කරනවා. ඕන තැනකට link කරනවා. right? අත unit wise කියලා graphs එන්නේ නැති units කියලා එහෙම නැහැ. for any unit graphs can be linked, right? Now just think of the units we have covered so far. Even Newton's laws questions we have graphs. Even in friction questions we have graphs. Rotational motion we have graphs. Okay, හැම තැනම graphs තියෙනවා. Starting from unit 1 to 11, right? Everywhere we have graphs, right? මේ all together තමයි මම කියන්නේ 10 graphs එනවා කියලා. ඒතර මෙයාගේ මෙන්න මේ වගේ gravity එකක් තියෙනවා. Right? Then the thing you are learning today and the skill that you are gaining today is much needed and it is going to add more value to your paper. 15% එන skill එකක් මේක. හරිනේ? ඒතර මේක ලොකු value එකක් ලොකු value එකක්. Whole mechanics is also for 20% of marks. Whole mechanics, right? But what we are doing today during this like 3 to 4 hours of time, right? 4 hours can 4 hours, sorry, 3.5 hours can 3.5 hours of time is going to add 15% overall, right? Mechanics වලට තමයි එන්නේ 20%. ඒතර මේක ලොකු gravity එකක් තියෙනවද? Right. Let's start without further ado. Okay, first look at the board. No, first write this down. I will explain this using few examples. Example 1, write down as example 1, write down example 1. A motor car starts its motion. A motor car starts its motion from rest and travels with a constant acceleration and travels with a constant acceleration right? Okay, look at here now for this scenario we are going to plot two graphs, right? And these two are the two graphs that you are going to plot for this given scenario. First one is final velocity with time and the second one is final velocity with 1 over time, right? අපි නිකන් මෙහෙම graphs එකක් අඳලා බලමු. Final velocity with time and final velocity with 1 over time, right? Now first thing, when a scenario is given is you have to model that scenario. To model the scenario we have to have an equation, right? Now first thing is you have to pick a relevant equation, a suitable equation to model this scenario. It says motor car starts from rest and accelerates with the uniform acceleration, and we are going to plot the variation between v and t, right? Now think of the variables given. U is given, acceleration is given, and we are interested about v and t. Then we can go with v equals u plus at. So likewise you have to pick the correct equation, pick a suitable equation, right? Then see how we are modeling this. This is what is happening. V equals u plus at. No, make a pick v equals u plus at. Now in the question it says u is 0. If u is 0, it says u is 0. Since u is 0 starting from rest, right? It says v equals 0 plus at and v equals at. So this is the modeled equation now for this given scenario, right? Now what we do is we have to identify variables from the equation with respect to the given graph, right? Something like this. Now as a standard axis, what is this standard axis? As a standard y-axis, right? Now, y is given, sorry, v is given as y, no? And t is given as x, no? Right? Until you are practicing, it's just fine to put y and x like this. But when you gain this skill, and once you gain the skill, no need to put y and x. Once you are comfortable, right? मैं आधा काम practice करने इंदा मैं yx दान right? නැත්තම් අපි එහෙම yx දාන්න ඕනේ නැහැ. හරිනේ? Now as y we have v, as x you have given t, right? Then identify these variables using standard variables. Now as t, what is given is x in the graph, and median x, right? And as v, what is given from the standard curve is y, right? Whatever it is as a multiplier, as a product with x is always gradient, right? Is always gradient. And once you do this, you will see a standard curve that you are familiar with, right? Now it says this is y equals mx. Y equals mx is a familiar curve, right? Which means this variation is going to follow y equals mx. Very simple as that, right? As plotting a graph, what we basically do is you have to rearrange the terms and take the equation to one of the standard shapes you know. And when you have a standard shape, right, what we are doing is plotting that standard shape, right? That is how all the standard curves you learned before are going to be used here, right? That's standard curves 25 විතර තියෙනවනේ. අන්නේ 25 මතක තියෙන්න වෙනවා. That is something you should be able to memorize. දැන් y equals mx කියන curve එක මතක නැත්තම් මෙතනින් එහාට ආයි ඉතින් දෙන්න බෑ. එහෙම බෑ. Now if you got y equals mx squared, then mx squared එකක් අදිනවා. If you got y equals m root x එකක් අදිනවා. Right? So basically what we do from our side is rearranging the terms and taking this to a standard equation or standard shape that we know, right? මේක තමයි අපි basically කරන්නේ, right? First technique. Other than this there are some other things as well that we can check, right? මේක තමයි අපි කරන first and the primary technique we have. Primary technique, right? මේකෙන් කරගන්න බැරි නම් තව techniques තියෙනවා as secondary and tertiary options, right? Primary එක මේක try කරලා තමයි අනිත් ඒවාට යන්න බැරි නම්, right? Is it clear? Right? මේ බලන්න මේකට කරමු. Now ආයිත් මේ equation එක දාන්න ඕනේ නෑනේ. Now this equation is valid for here as well. Same scenario. ඒ කියන්නේ v equals AD now. And now we have a confirmation for A. A is a constant. ඒක given A is constant. නේ ඒකයි constant gradient එකක් එන්නේ. Because before plotting it's a verification. It's better to get that verification whether m is changing or constant. It's a constant, right? V equals AD. Now, in this kind of a one, now x is 1 over t, y is v. Y is already visible here, but x is not visible. I need 1 over t, but instead I have t. In such cases, what we do is, we have to reshape this equation. That is called reshaping. That is called reshaping the equation. Right? When you reshape an equation, we can't do any harm to the equation, original equation, right? Only the shape. Shape ke lage anne, the appearance of the equation is going to be changed. Shape එක කියලා කියන්නේ appearance එකට. maths වල කියන්නේ shape එක කියලා. That's the shape of the equation. Right? මෙන්න මේ idea එක දන්න ඕනේ. x is 1 over 1 over x නෝ මේව ලියන්න පුළුවන්. x can be written as 1 over 1 over x, right? මේව ලියන්න පුළුවන්. Because you know 1 over x මේක division එක multiply එකක් කරලා reciprocal දාලා ලියන්න දන්නවනේ. This can be written as 1 over x over 1 whole number. So that is x, right? Which means 1 over 1 over 2 is 2, 1 over 1 over x is x, right? Now instead of t, since I need to create 1 over t here, right? What if I reshape the equation like this? 1 over t. Have I done any harm to the equation? No, if you simplify this, again the original equation comes. But my requirement is satisfied now. What was my requirement? Creating one node. It is satisfied. See? Now identify variables again. Identify variables again. Identify variables. Now one node is acting as x. One node is here. One node is here. Then this is not x, that is one node x. Right? One node in x again, that is one node x. Whatever it is as a product with independent variable is gradient, always gradient. And this is y, a standard shape. Y equals m1 of x, inverse curves, right? Which means this is going to be inverse, right? Inverse curves. So likewise, what we do from our side is taking a given equation or a given scenario. First, if a scenario is given, first you have to take it to an equation, right? And then you have to reshape and rearrange the equation as you can get a standard curve we know, right? If an equation is given, no need to model this, right? Model करने के लिए हम क्या करते हैं? तो equation याद दुन्नो थे माँ ඊට වඩා ලේසි. මේක equation එක දුන්නොත් පිළිම මෙතනින් පටන් ගන්න පුළුවන් මෙතනින්. If the equation is given, right? Now you should be able to do this when a scenario is given. Scenario එකක් දුන්නා scenario එක model කරා, model කරලා equation එකක් ගත්තා. Equation එක අපේ standard shape එකකට ගෙනාවා. Standard curve එක ගන්නවා. ඕක තමයි කරන්නේ. Right? Clear enough? Right? Okay. Take it down and ask if any questions meanwhile. Take it down and ask if any questions meanwhile. When you reshape an equation, you can't harm the equation, right? If you simplify this line, again original equation should come, right? That is what we call reshaping. Whatever it is in multiplication with x is gradient, yes. But gradient can be changing or constant, that you have to check and make sure whether it's a changing gradient or a constant gradient, right? So whatever it is, multiplying with x is gradient. Okay, finished? Write down below with a red pen. Write down below with a red pen. First point, write down in red, first point. Model the given scenario, model the given scenario, using a relevant equation, using a relevant equation based on given data, and the requirement, based on given data and the requirement, Next point, rearrange the terms of the equation rearrange the terms of the equation, rearrange the terms of the equation to plot the graph to plot the graph with given axis, to plot the graph with given axis. Next point, reshape the equation to match given axis where necessary. Next point, convert given variables of graph to standard y and x variables. Last point, plot the variation of respective standard curve. Plot the variation of respective standard curve. Okay. Let's see another example. Example 2. Write down. A fruit falls under gravity. A fruit falls under gravity from a tree. A fruit falls under gravity from a tree. Right here. Okay, look at here. A fruit falls from a tree under gravity, right? Then initial velocity is 0, right? Now we are going to plot this variation with the displacement, right? With the displacement measured from the tree, yeah? Something like this. The scenario is something like this, if need. The fruit falls from a tree, right? Like this. Initial velocity is 0. It falls under gravity. And we are going to plot this variation with the fallen height, right? Okay, to model this, because my interest is on S and T now, displacement and time, what's the relevant equation you can use? S equals ut plus half AD squared, applied downwards. S equals ut plus half AD squared, right? S equals u is 0, so ut becomes 0, half, it falls under gravity, g t squared. Then the modeled equation is this, half gd squared, right? It's done. Now identify variables, right? So until you get this practice, you can put y and x, right? But later on, Once you master this, don't put y and x. Make diya bala make a gun. Right. Now t is x. This is t squared. Then this should be x squared. Right. So whatever it is, multiplying with independent variable is gradient. And s is given as y. Right. And make sure whether this gradient is constant or varying before concluding the shape. Adhisyari මේ gradient එක පාඩ m කියලා දැක්කට you are seeing that as m, but what if that gradient changes? එතකොට වෙන shape එකක් නෙන්නේ. First make sure whether it's constant or changing. Half is a constant, g is a constant, so does gradient is constant. Then mx squared, right? mx squared කියලා කියන්නේ අපි දන්න shape එක. Right? Then for the second one, right? Model equation එක මම ගන්නවා s equals half gt squared, right? gt squared. Now in the second one, whole t squared is given as x, right? And s is y. Now whole t squared is x now, right? මේ t squared එකටම x කියලා දීලා තියෙනවා. Whatever it is multiplying with x axis is gradient, and this is y. Now it becomes y equals mx. Same equation, same scenario, but when axes are different, shape becomes different. Right? Last one with 1 over t squared. Right? Our equation is x equals half gt squared. 1 over t squared is not visible here. Then you have to create it. Right? When you create it, you have to create without harming the original equation. Reshaping. Right? Reshape this. So you can reshape this as 1 over t squared. No change. If you simplify this again, t squared comes. Right? 1 over t squared. 1 divided by 1 over t squared. Reciprocal of t squared over 1. Reciprocal again t squared over 1. Then t squared comes. Right? Now, requirement is satisfied. 1 over t squared is our x. Right? This is y. Now, 1 over t squared is x. Whatever it is multiplying is gradient. This is y. Y equals m1 over x, right? If they are at numerator and denominator, don't check again. That's an inverse curve. I'm good බලන්න ඕනේ නැහැ. Inverse curves වලට එක shape එකයි තියෙන්නේ. එහෙනම් inverse තමයි අදින්න lazy one. Whether gradient changes or whatever the index power of x, වැඩක් නැහැ. If they are at numerator and denominator, all are inverse curves. Right? මේමයි curves වල එන්නේ. Clear, right? Take it down. හරි. මගෙත් එක්ක තව එක example එකක් මම කියලා දෙන්නම් ඊට පස්සේ තනියෙන් අදින්න දෙන්න. This is our primary technique. මම මේකෙන් පස්සේ secondary technique එකක් කියලා දෙන්නම්. Right. How can gradient change in graph 1 and 3 if half g is constant? Listen, that's a good question. Half g is constant. Half g is constant. And according to the graph, its gradient changes. Right? What happens is this. Now, when we plug t inside this t also, that's a t squared, no? Inside this t also, there's another coefficient comes. Coefficient කියලා කියන්නේ මේක ඇතුළේ තව constant value එකක් simplify වෙනවානේ. අන්නේ value එක ආවට පස්සේ තමයි මේ වැඩේ වෙන්නේ. ඒ කියන්නේ now apply some values and see. If you apply 2, it becomes 4. If you apply 3, it becomes 9. Rapid increase එකක් තියෙනවා කියලා පේනව නේද? When you apply 2 for this one, right, it becomes 4. When you apply 3, it becomes 9. When you apply 4, it becomes 16. 5, it's 25. So likewise, it's rapidly increasing because for that gradient, there is a contribution from this variable as well. එහෙම graphs තියෙනවා. ඒ gradient එකට මෙයාගේ contribution එකක් තියෙනවා. එතකොට without this contribution, this part is constant. But the actual gradient is with the coefficient value which is coming from this variable. Right? එහෙම graphs තියෙනවා. So if you think further, that's a good question. Okay, finish. And as a secondary technique, we can do this for a given graph. If you need to check x intercept and y intercept, right? Simply what you can do is make x0 and check the y value and make y0 and check the x value. Right? ඒකෙන් පොඩි idea එකක් ගන්න පුළුවන් graph එක ගැන. Whether it goes through origin or whether it's going to intersect y or intersect x or something like that. Right? ඒකත් අපි use කරන technique එකක්. That's a second technique we have. මෙහෙම කරලා idea එකක් ගන්න බැරි නම් as a second thing, you can check x and y intercepts. Now, as an example, right, in this one, when t becomes 0, x becomes 0, no? So it starts from origin. Likewise, you can get a verification by checking those two. When x becomes 0, y intercept comes. When y becomes 0, x intercept comes. Right? Write down below with red pen. Write down below. To check to check intercepts of a graph, to check intercepts of a graph, to check intercepts of a graph, put a comma and write down below first bullet point, make x0 and find y intercept. Make x0 and find y intercept. Second bullet point, make y0 and find x intercept. Make y0 and find y intercept. Right. Okay. Morning given, make x0 and find y intercept, then make y0 and find x intercept. Right? How t squared becomes x? T squared becomes x. This one. T squared is given as x variable, x axis of the graph. X is given as y axis of the graph. Right. So I will discuss one last example with me and then we'll go to the ones given here. Right? Okay, next. Write down as example 3. Write down as example 3. Okay, example 3. The car starts. Sorry, don't say car. A ball starts. A ball. A ball starts. A ball starts. A ball. A ball starts. A ball starts. A ball starts. To fall vertically downwards. To fall vertically downwards. A ball starts to fall vertically downwards. A ball starts to fall vertically downwards. When it is hit, when it is hit, when it is hit, with a velocity, with a velocity, with a velocity, u at the beginning, with a velocity u at the beginning. Okay. These are the ones we are going to plot. V with time. V with time. And V squared with S. V squared with S. Okay, let's see. Read the scenario given and tell me what's the relevant equation to model this. What's the relevant equation to model this? First, the variation between V and T. What's the relevant equation? V equals U plus AD, right? V equals U plus AD. It's a vertical downward motion I gave. Then vertically downwards, apply V equals U plus AD. And C V equals U plus AD vertically downwards, right? V equals U is given as U plus A is G. It falls under gravity, T, right? Now, identify variables. Identify variables. T is given as X, V is given as Y. See? T is given as X. T is given as X. Whatever it is, multiplying with X is gradient, right? And V is Y. And this part which is added after mx term is, it has to be the intercept. See, right? If you need to make sure whether this is the intercept, right, you can do that secondary technique I just explained. Make t 0. When t becomes 0, gt becomes 0. Then it says v equals u. When t becomes 0, v equals u. That's the intercept. Right? Right? The main one, standard shape here. Y equals c plus mx. Mx plus c. C plus mx can mx plus c. So that's a standard shape. And you can find this intercept, that is u. Find Ganymede, u equals c. That's a positive intercept. Okay, finish. Give this a try. Give this a try before I explain. V squared with S. V squared with S. Give it a try. Finish. Correct. Good. Equation hari. Equation hari. Model කරගන්න. Model කරලා variables ටික identify කරගන්න. එන shape එක ගන්න. අනේ සමහර equation එක. Now we are going to plot V squared with S. ඒතර S තියෙන equation එකක් නේද? S එක. ඔව්. ඒක ගන්නවා. Pick a relevant equation based on given data and the given access. Access කියලා කියන requirement එක තමයි requirement එක. What's the shape? හරි. හරි variables identify කරගන්න. හරි. හරි ඉතින් ඔක දැන් ගාන හදලා ඉවරයි. මේක x v squared වලට y කියලා දාගන්න පුළුවන්. ඊට පස්සේ හරි මේකෙන් ඒකත් හරි. ඊට පස්සේ මේක constant එකක්ද මොකද්ද කියලා check කරගන්න. ඒක constant එකක් නම් ඒක intercept එක. ඒක තව විදිහට check කරන්න පුළුවන්. අර මම කිව්ව විදිහට ඔන්න x0 කරලා ඒ කියන්නේ t0 කරලා t නෙමෙයි s S කියන මේ axis එක 0 කරලා v squared වල value එකක් එනවද කියලා check කරගන්නත් පුළුවන්. දැන් මේකට scenario එකේ තියෙන values plug කරන්න. ඒ කියන්නේ now if it falls under gravity acceleration should be gravitational acceleration. Right? මේක plug කරලා ඔය දැන් තියෙන ඔය equation එකේ තියෙන raw equation එක. equation එක මුලින් rearrange කරගන්න ඕනේ. rearrange කරගෙන තමයි variables ටික identify කරගන්නේ. Right? Okay, see? Okay. Relevant equation is v squared equals u squared plus 2as. 2as. Right? Now, s is given as x. V squared is given as y. Right? Apply this downwards for this given scenario. දැන් මේ scenario එක මතක නැත්නම් මේකට පොඩි diagram එකක් අඳ ගන්න. Right? මෙන්න මෙහෙම scenario එකක් මම මේ ඉන්නේ. Right? Something like this it was. Starting with initial velocity u falling under gravity. A ball on no scenario එකක්. Right? And vertical height fallen here is s. This is the given scenario for this one. This is the given scenario. Right? If you need a sketch, you can have a sketch. Right? Okay, now v squared equals u squared is same u squared plus 2gs. 2gs. Identify variables. Identify variables. S is x and 2g multiplier of x gradient. U squared is a constant value because once the initial velocity is given, it's given. It cannot be changing again. Right? It cannot be changed again. Right? Initial velocity එකක් දුන්නා නම් මේක එතනින් පස්සේ ආයෙ මුකුත් කරන්න බෑ. If the initial velocity is given at the initial point, it's given and it's a constant. Initial velocity එක පස්සේ වෙනස් වෙන්න බෑ. And if you need to make sure it, right, make x 0. When s 0, right, v squared equals u squared. Right? ඒ කියන්නේ plus value එකක් මෙතෙන්ට එනවා. Right? ඒක තමයි මේ intercept එක. See, and whole v squared is given as y now. Right? Again, it is mx plus c. mx plus c, and gradient, sorry, intercept here is q squared. Intercept here is q squared. Right. Clear? Sanacharu? Clear? Online? Any questions? Any questions? Any questions? For these axes given in the tube, I will give you the context. Context again, I will give you the equation and the relevant context. Right? Right? Otherwise, just by looking at M and V, you don't know which context is given. I will give you the context. Right? Clear? Right. So let's move on. Go to page number 1. Page number 1 of this one. Page number 1. Question 1. Right? For first 4 questions, listen. For first 4 questions, the context is linear momentum. Right? Context is linear momentum. Right? Okay. Mention it somewhere. First 4 is for linear momentum. I will erase this. Okay. What's the equation of linear momentum? Mass into velocity, mv. And according to conservation of linear momentum, linear momentum is a conservation. So it is a constant value. It's a constant. It's a constant. Linear momentum ke constant hai, right? Okay, page 1. Page 1, right? So we are in first 4 graphs, 1, 2, 3, 4, right? This is the context, linear momentum. Okay, linear momentum. Can you try the first one? Can you try the first one? Or should I explain the first one? Yeah, correct. Right. Linear momentum is a conservation. Right? Linear momentum is a conservation. Right? Equation ke danna thamavuna. Equation ekya na. Linear momentum is mass into velocity. Mass times velocity. Right? This is linear momentum. There is a conservation. So this product is constant for a given object. Right? Then, which means mv is constant. Say k, api constant ekata k kiyala hidamu. Let's assume this as k. Right? Then this is the relevant equation. Right? Right. First one. M with v. M with v. Second one, m with 1 over v. M with 1 over v. Next one, 1 over m with v. 1 over m with v. Right? Try kala balanda මම කියලා දුන්නේ නැති ඒවත් මේක දැන් තියෙනවා. Because we are going to discuss them. 1 over m with 1 over v. 1 over m with 1 over v. Try kala බලන්න. What about the first one? First one, mv is constant. mv is constant. So rearrange the equation. mv is k. Right? My y-axis is m. Right here. X-axis is v. Y-axis is m. Then subject m. Because always our any standard shape starts as y equals no. So subject y. Subject y, which means you have subject m. Subject m. M equals k over v no. M equals k over v. If I isolate these terms without harming the equation, we can write this as k1 over v. No issues, no worries. K1 over v k over v. No change. That's a reshaping, right? Reshaping. Hurry. Then variables identify variables. V is x, then this is 1 over x. 1 over x. And k is a constant value. It multiplies with x, so that is gradient. And m is given as y. Y equals m1 over x. That is an inverse curve. Second one? What that? What about second one? Correct. Good. Okay, one pen. Second one. Correct. 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 Good. මේකේ already 1 OV තියෙනවා. දැන් මේ reshaping එක වැරදි. මේක simplify කරොත් මේ line එක එන්නේ නැහැ. ඇයි මේක තියෙනවනේ k times 1 OV තියෙන්නේ. 1 OV is already there. Right? 1 OV is already here. Nothing to do. See? Second one. Second එකේ මේ equation එක මම කෙලින් මෙතෙන්ට ගන්නවා. Same equation no. M equals k 1 over v. Right? Now 1 over v is already here. No need to reshape. Reshape කරන්න ඕනේ නැහැ දැන්. 1 over v is x and m is y. Now this whole 1 over v is x now. This is gradient. Right? And this is y. Y equals mx. Y equals mx. What about third one? Third. What's the shape of the third one? If 1 over m is not here, you have to create it without harming the equation. That is what we call reshaping. That is what we call reshaping. Reshape karan. Online, any answers? Any clue about the shape here? You can put the standard curve to the chat. mxo, m root x, inverse, trigonometric, right? So likewise. What's the curve? Sanachari therone? Second day, therone? Second day therone? ඔයාට already 1 OV තියෙනවා නම් ඉතින් ආයි 1 OV create කරන්න දෙයක් නැහැ. reshaping එක තියෙන්නේ මොකක් හරි term එකක් දැන් නැත්තම් ඔයා එක create කරගන්න ඕනේ without harming the equation. තියෙනවා නම් ආයි create කරන්න දෙයක් නැහැ. That's already there. Right? Plus දැන් එහෙම mistake එකක් කරපු ගමන් මේක වන්න පුළුවන්. අර ඔයා කලින් තියලා තිබ්බ line එක simplify කරා නම් මේක එන්නේ නැහැ. No. හරි. Sorry. 1 over m with 1 over v නේ. හරි. Correct. Good. Okay, see, third one. Now, as an equation, we have mv equals k. अब मेथड में start करूँ because I have to create this again because 1 over m is not visible in this equation yet. Right? mv equals k. See, mv equals k. Right? My first thing is creating 1 over because 1 over m is y and v is x. Right? Subject 1 over m because I need to subject y. To subject 1 over m, cross multiply this, then we can write v over k as 1 over m. No? Cross multiply m to right hand side and cross multiply k to left hand side. Right? Now my one of the requirements is satisfied. 1 OM is created, right? To make this more familiar, let me switch the sides. Then 1 OM equals, right? 1 over K M. 1 OM equals 1 over K M. Right? If you have 3 over 2, this can be written as 3 times half, no? Something like that. Right? Nothing changes. Nothing changes. Right? Now, identify variables. Identify variables. V. V. Okay. Identify variables. V is given as X. V is given as X. And whatever it is, multiplying with this is gradient. Take a K, the 1 over K, the K squared doesn't matter. That's a gradient. Right? And 1 over M is Y. It is again a Y equals Mx. It is again a Y equals Mx. It is again a Y equals Mx. How about the last one? Correct. Good. No, yours. Overall. Check last one again. One over M and 1 over V. Do the relevant reshaping you need. Do the relevant reshaping you need. Okay, last one. See, 1 over M with 1 over V. I will start from here because 1 over M is already created by this equation. No? 1 over M equals 1 over K V. Make an equation again. Right? Now 1 over M is already here, but we are seeking 1 over V now. Create 1 over V. If you need to create 1 over V using V, then follow that same thing I explained before. V can be written as 1 over 1 over V. Then say without harming this equation, what if I rewrite this as this? Same thing comes if you simplify it. Right? Identify variables. 1 over M is Y. Right? And 1 over V is X. So this is 1 over X. This gradient inverse. Okay. For next 4 questions, context is gravitational potential energy. For next 4, gravitational potential energy. For next 4, gravitational potential energy. PE, gravitational potential energy, with H1 over H squared, then 1 over PE, 1 over H, right? Start next 4. Context is gravitational potential energy. Five. Context is gravitational potential energy. I will start in 2 minutes. For next 4 questions, context is kinetic energy. Not next 4, next 6. For next 6 questions up to 14, context is kinetic energy. यहाँ प्रोडक्ट है මේකත් එක්ක මල්ටිප්ලයි වෙලානේ තියෙන්නේ. ඒතර ඒක ඉන්නේ ග්‍රේඩියන්ට් එක ඇතුලේ. x එක්ක මල්ටිප්ලයි වෙන terms 10ක් තිබ්බත් 10ම ඉන්නේ gradient එකේ තමයි. add වෙන හරි subtract කරන term එකක් આવොත් තමයි intercept එකට යන්නේ. Whatever it is multiplied with independent axis is always gradient. Okay, what about this one? Potential energy with height. What is our general equation? Potential energy is mgh, gravitational potential, mgh. Right? Gravitational potential energy is mgh. mgh. Already h is here. H is x. And both mg, right? Both multiplies with h, gradient. Right? And this is as y equals mx. Y equals mx. Right? Second one, create one more h. Potential energy is mgh. You can reshape this as 1 over h. No harm to the equation. No harm to the equation. 1 over h. Right? Now 1 over h in this scenario is x. So this is 1 over x. And whatever it is multiplied, gradient. And this is y. M root x, sorry, m1 over x inverse. m1 over x inverse. Graph වලින් lazy නේ. නැත්තම් lazy. කට්ටිය බොරුවට බය වෙන්නේ. Once you know these fundamental techniques and the concepts, right? It's nothing. පාඩම් කරන්න නැතුව ගන්න පුළුවන් ලකුණු තමයි graphs කියලා කියන්නේ. Once you have this skill. Right? Nothing to be scared or nothing to be scared of, right? If your knowledge on these fundamental concepts is solid, right? Easily you can plot all graphs you are getting, right? Not only in physics, may graphs you are getting chemistry la graphs andina puluwa. Maths wala up to some extent you can do. Chemistry wala hem puluwa. ICT wala graphs. Eh? I don't know. Ask if any questions. Ask if any questions. Nah. 7 එක check කරන්න. No. 7 එක. 7 එක reshape කරන්න තියෙන්නේ. See? equation is potential energy equals mgh. Now I need to create h squared here. Look at here, is a new one, right? You didn't do this type before, right? I need to create h squared, right, without harming this equation. h squared right? We need to put h squared into this without harming the equation. What if I do this, right? What if I do this? If you simplify this, again, root h squared is h, so mgh comes, right? That is the reshaping part. Then what's the shape? What is this shape? What is it? What shape? Oh. First time shape now h squared is x. root x because h squared is x. Whatever it is multiplying with this is gradient. This is why m root x is a standard curve. Okay, last one, that is easy. 1 over P with 1 over H. Potential energy equals mgh, no? Right? You can put both sides 1 over without harming the equation, right? Like this. You can put both sides 1 over without harming. If y equals x, right? 1 over y equals 1 over x. You can put both sides. We can literally do anything to both sides of the equation. No? See, 1 over like this. 1 over h is x now. Anything which is multiplying with this one is gradient. 1 over p is y mx. Right? For next 6, context is kinetic energy. For next 6 questions, context is kinetic energy. Okay, kinetic energy questions. Start. Kinetic energy with V 9. Then kinetic energy with V squared 11. Kinetic energy with 1 over V. Kinetic energy 1 over V 12. Kinetic energy 1 over V squared. Next, kinetic energy V to the power 4. And 1 over K 1 over V squared. 1 over K 1 over V squared. Right. Equation of kinetic energy. Kinetic energy equals half mv squared. Right. Then V is as x now, kinetic energy is as y now. Then if V is x, this is x squared. Whatever it is multiplying with x, gradient. This is y equals mx squared. Right? Y equals mx squared. Now you can keep doing. So after 14, V and h means plot variations for final velocity of an object starts from rest. After 15, V and h for an object starts from rest. V and h for an object starts from rest after 15. Right. So if whole V squared is considered, it becomes mx. Right? For this one, it becomes mx because kinetic energy equals, if you didn't do, you can look at the board, otherwise you can continue. Right? Half mv squared. Whole v squared is given as x now. So this is m, this is y equals mx. Kinetic energy with 1 over v, create 1 over v. So this can be rearranged as 1 over v squared. No? 1 over v squared. No change. But I need 1 over v, not 1 over v squared. We need 1 over v. How to get 1 over v? What if I rewrite this as 1 over v whole thing squared? Still there is no change, no? Because 1 squared is 1 and v squared is v squared. Right? Now our requirement is fulfilled. Right? 1 over v is x, so this is 1 over x squared. And this one is gradient. This is y, right? If x and y are inverse, that is an inverse curve. For fourth one, you can get the equation from here itself. Kinetic energy is half m 1 over v squared, right? So 1 over v squared is given x m y. This is y equals m 1 over x. Still that is inverse. Still that is inverse. With v to the power 4. With v to the power 4. මේක අර කලින් වගේ එකක් ක්‍රියේට් කරගන්න ඕනේ. Then kinetic energy half m v squared can be written as the square root of v to the power 4. Because square root is the index of the power of half. Index simplifications. Indices. Grade 9 or something. Right? මෙහෙම ලියන්න පුළුවන් නේ මේක multiply වෙනවා කියලා අර පොඩි කාලේ කියන්නේ. Right? Requirement is satisfied. V squared එක තියෙනවා. V squared තමයි x, then this is root x, gradient y equals m root x. 1 over k with 1 over v squared. Put both sides 1 over. Right? If kinetic energy equals half m v squared, right? You can put both sides 1 over as 1 over k equals 1 over 2 becomes 2. Right? 1 over m 1 over v squared. Right? 1 over 2 කියලා කියන්නේ 2 නේ. මම ඒක එකපාරින් ලිව්වා. 1 over v squared is x now. Anything which is multiplying with this gradient, and this whole thing is y equals mx again. Y equals mx again. Ask if any questions. New shapes කියන ඒවා මම පොඩ්ඩක් explain කරා. තාම ඊට පස්සේ new shape එකක් තාම ආවේ නැහැ. V with root h. V squared with h. This one. Put both sides 1 over at once. Equation එකේ දෙපැත්තට අපිට මොනයක් කරන්න පුළුවන්? right? දෙපැත්ත 1 over දාන්න පුළුවන්. 1 over KE 1 over half. 1 over half කියලා කියන්නේ 2. ඊට පස්සේ 1 over v squared. right? ඒක එහෙම තේරුම් නැත්නම් cross multiply කරලා ගන්න පුළුවන්. If you didn't get this, what you can do is cross multiply KE to this side and cross multiply other terms to the other side. එතකොට මේක එනවා. Both are fine. V squared with h, V squared with 1 over h. Then V with h squared. Yes. Yes, sir. මේ context එක මේක for 15 and onwards, 15 onwards, an object falling from rest. Object falling from rest. Context is this: object falling from rest. Model it and get the equation and plot how many graphs there are? 6. Object falling from rest. Kinetic energy regarding it. Ask if any questions. For the rest, friction. F and R variations friction. Context is friction. Frictional force. Okay, what's the relevant equation? V and H. V squared equals U squared plus 2as. Right? Here H is fallen height. Right? H is fallen height. An object falling from rest. H is fallen height. Where H is fallen height. Right? What shape? First second. Yeah. V equals root 2g scale n equals root 2g scale n. Oh, what's the equation you used? It's but the thing is, don't use it. Why? You don't have any idea about how time varies there. Time is a variable. එතකොට දැන් වාගේ variables කීයක් තියෙනවද? 3ක් තියෙනවා. එතකොට idea එකක් ගන්න බෑ. Right? Always we have to have 2 variables because we have 2D graphs. Because sometimes there can be something hidden inside that T that you don't know. It varies. If T is not given as a variable, don't go with an equation which has T. So apply V squared equals U squared plus 2as. Right? That's the best equation. u is 0, then v squared equals 2gh. So v equals root 2gh. මෙන්න මේක තමයි equation. v equals root 2gh. Right? Now, for better understanding, we can rewrite this as this. Root 2gh can be written as root 2g times root h. No? Right? Okay, now h is x, then this is root x. And this whole thing is gradient. This is y. Y equals m root x. Y equals m root x. Then v with 1 over h. V with 1 over h. V with 1 over h. Right? मैं मेरे में create कर रहा हूँ. V with 1 over h. See, v equals root 2g. What if I write this as this? No change, no? Right? No change, no? Now, this is y. This is y. This one is m. And 1 over h. You have to write this using 1 over h. 1 over root h. 1 over h. How to write? How to reshape this to 1 over h? V equals root 2g 1 over 1 over h whole thing square root. No change because square root of 1 is still 1. Right? Square root of 1 is still 1. Yeah, root x over y equals root x over root y. මේකට ඉස්සර ඔලසල් පාඩමකුත් තියෙනවා. මොකද්ද? තියෙනවා? ඒක තමයි. අන්න ඒක යූස් කරා. එහෙනම් මේක මට ලියන්න පුළුවන් as root 1 over h. root 1 කියන්නේ 1. root h කියලා කියන්නේ root h. හරිද? That's it. It's done. Now 1 over h නේ 1 over h කියන්නේ මෙතන තියෙනවා. Then this is 1 over root x. Whatever it is multiplying is gradient y. Y and x inverse නම් බලන්න එපා මොකුත්. That is inverse. වැඩක් නෑ බලලා. That is inverse. Third one. Third day lazy. V with root h. Equation is V equals root 2g root h. Right? Root h is given now as x. May okkama thamai x. And this whole thing is gradient. This is y. Y equals mx. Right? V squared with h. මෙතන equation එක තියෙනවා. V squared equals 2gh. V squared equals 2gh. This is x. May be a gradient there. And this whole thing V squared is y. Still y equals mx. V squared with 1 over h. මෙතනින්ම create කරන්න පුළුවන්. V squared is 2gh no. Then you can write V squared as 2g 1 over 1 over h. 1 over 1 over h. So this is y equals gradient 1 over x inverse. Right? What about the last one? V with h squared. V with h squared angle. What's the shape? One line. What's the shape of V with h squared? 20. V with h squared 20. Yes. Good. See, last one. V with h squared. The equation we know is V is root 2g root h. Now you have to include h squared somehow into this, right? Root h ka kennathone. So what if I write this as 1/4 power of h squared? Index simplifications. මේක simplify වෙලා half කියලා එනවනේ. Half means root h. Indices. Now h squared is x. මේ තියෙන්නේ එතකොට 1/4 of x. And this is gradient and y. 1/4, any power in 0 and 1 has the same shape between 0 and 1. Right? Use your simple maths knowledge, index simplifications, indices. Before next set of questions, let's go to some trigonometric ones. Go to 29. 29. Medium past 29. And for 29 onwards, the context is this. Listen, for 29 onwards, the context is the equation is coming from simple harmonic motion, right? That is x equals a sine theta. This is an equation coming from simple harmonic motion. X equals a sine theta, where a is amplitude. Amplitude is a constant, right? Where a is amplitude. That's a constant for this scenario. Right? This is a context. Right? If any questions you can ask, right? You can try 29 onwards, 29 to 34. We have already finished 20 graphs now. Right? Once you get the skill. We have already finished 20. Right, go to 29 onwards. X and sine theta, x with theta, x with 1 over sine theta, x with theta squared. I will start in 2 minutes. X with sine theta. X with theta. x with 1 over sin theta. X with theta squared. Sin theta with x. Theta with x. What's x in the equation? Displacement. X in the equation is displacement. Displacement, right? If you need to know the equation, displacement, and theta is called phase angle. Phase angle. THAC, phase angle. What is the shape of the first one? First candidate, 29. Correct. Second depth, hari. Third depth, hari. Fourth depth, hari. 33th, hari. 34th ആണ്. അതിനകത്തിനോട് വേണ്ടേ? Good. මේක check කරන්න. මේක මෙහෙම නෙමෙයි. ඔයාගේ දැන් x කියලා කියන්නේ whole sin theta. ඒකම sin theta x ඉන්න sin එකක් එන්න බෑනේ. Whole sin theta is x now. Right? Whole term sin theta is x. Okay, first one. See? X equals a sin theta. See? First one. X equals x equals a sin theta. Right? This whole thing sin theta is given as x. මේ තමයි x. Right? මේ sin theta කියන ඔක්කොටම x කියලා දීලා තියෙන්නේ. Whole sin theta is x now. This is gradient and x is y. Y equals mx. Right? So even though there's a trigonometric term, if it is not varying trigonometry, again according to trigonometry, it is not going to follow a trigonometric curve. Right? මේක vary වෙන්නේ sin theta ඔක්කොම මෙතෙන් ඩයිවිලා තියෙන්නේ x කියලා ඉන්නේ. Now if you got something as sin x, අන්න variable එකට එනවා. දැන් variable එකේ තියෙන්නේ x කියලා විතරයි. Not sin x. ඒක different ah. මේ equation එකේ sin කියලා තිබ්බා කියලා මෙතන sin ඇවිල්ලා නැහැ නේ. That is x. එහෙනම් මේ තියෙන mx. හරි. second එක කරාට පස්සේ ඒක වැඩේ තේරෙන්නේ බා. x equals look at here. A sin theta. Now theta is given as x. Right? එහෙනම් මේ theta තමයි x. Right? sin කියන එකට මොකක් කරන්න බෑ. It's still there. So this is sin x. Sin x now. Whatever it is multiplying with the gradient, make a term එකක්. So this is gradient and this one is y. මෙන්න දැන් variable එකක් ආවා. Y equals m sin x, which means this y varies according to the variation of sin x. Right? This y varies according to sin x. අන්න එතකොට තමයි sin variable එක එන්නේ. Right? Sin variation එක මෙහෙම එකක් නේ. Right? And get the variation between 0 and 90. Right? Plot the variation between 0 and 90. Plot the variation between 0 and 90. Plot the variation between 0 and 90. If a trigonometric term comes as a trigonometric variable, then it is going to follow that respective trigonometric function. Write down below 30th. Write down below 30th with a red pen. Write down below 30th. Below 30th. Below 30th one with a red pen. If a variable follows a trigonometric if a variable follows a trigonometric function, if a variable follows a trigonometric function, if a variable follows a trigonometric function, it behaves according to the respective trigonometric variation, according to the respective trigonometric variation within brackets between 0 and 90, within brackets between 0 and 90, because we will only need between 0 and 90, right? Between 0 and 90, between 0 and 90, 0 and 502. Okay, is it clear? What about the third one? X 1 over sine theta, x equals a sine theta. That is same as the previous one we did. A equals, this can be written as, without harming the equation, 1 over sine theta, no? Right? So this is 1 over x gradient y equals m1 over x inverse. X with theta squared. Okay, look at here again. X equals a sine theta. Now I need to create theta squared, right? Creating theta squared is something as we did before. Theta squared root take no harm. No harm to the equation. No harm to the equation. Right, now identify variables. Identify variables. Theta squared is x. Then I made in a root x. But that is inside this. So this is sine root x. Root x and sine root x at the m and y. Y equals m sine root x. Sine function that's a sine variation. Right? Sine variation between 0 and 90 for the sine variation. Sine function sine variation. This follows a sine variation. Sine theta with x. Sine theta with x. X equals a sine theta, subject sine theta. Sine theta is given by 1 over a x. Cross multiply. Cross multiply and subject sine theta. Sine theta is y now. Sine theta, whole thing sine theta, complete sine theta is y. And x is x. Median gradient mx. Theta and x. Theta and x. Theta and x. Okay, then subject sine theta again, because I need sine theta to be in y-axis. Theta ganna sine theta ganna. So I need theta to be in y-axis, right? Then sine theta equals 1 over a x. Sine theta equals 1 over x, right? Theta is y. So this is sine y. Sine y. Idea is this is a sine variable. Sine y is a sine variable. Sine function. Right? Median x madamai. Right? mx. If a sine variable comes, that's a sine variation again. Right? It's a sine variation. Method sine variation is sine variable la kaana sine variation. Y ge ribbat ehema thamai. Right. If you have finished up to here, go to page 7, scenario 3 and try it. Page 7, scenario 3. Page 7, scenario 3. Page 7, scenario 3. Scenario 3, ball thrown vertically upwards. Ignoring air resistance. X-axis is time, y-axis is v. VT graph VT graph for a ball thrown vertically upwards. Give it a try. Ask if anything. Ball thrown vertically upwards. Try that. Ball thrown vertically upwards. A ball thrown vertically upwards, and I need you to plot for the entire motion until it returns to ground again. Until it returns back to ground. A ball thrown vertically upwards. And use the practicability as well. Practicability, common sense, everything. General knowledge, ඔක්කොම use කරන්න. Ball is thrown vertically upwards. Right? General knowledge එකත් ඕනේ. Then at the maximum point, its velocity should be 0. That's coming from our knowledge. So you can easily reach the final result easily when you connect everything with the question. That's a better approach. No. Partially correct. Only one half is correct. Think about directions as well. You are plotting velocity. It's a vector quantity. It's a vector quantity. If the direction changes, vector changes. When vector changes, its sign changes. Right? Okay, see about this type of a variation. Ball thrown vertically upwards. This is a known context. We have discussed in linear motion. The ball is thrown vertically upwards. So it will reach a maximum height and it's going to return to the ground. Something like this. And if it is thrown, a non-zero initial velocity should be here. Right? A non-zero initial velocity should be given. Otherwise, now without giving a velocity, this is naturally not going to go upwards. Right? So we have to give a velocity. Motion something like this. Right? And this motion is under gravity. Right? Under gravity. Under gravity. Direction of gravitational acceleration is vertically downwards. Right? So when this is reaching from hand to the maximum point, is it accelerating or decelerating? decelerating because gravitational acceleration acts downwards, and velocity becomes 0 at the maximum point. And returning motion comes from here to here, not against the gravity, but with the gravity. So it is an acceleration. Right? Now to model this for the first part, first part model first equation because there are two directions. Since there are two directions, now I have an idea in mind already that it is going to be negative because velocity is going to be switched, altered at the maximum point. If velocity is switched, velocity is a vector quantity. Then if velocity is switched, then sign switches. And sign එක switch වෙනවා කියන්නේ දෙපැත්තටම මේ ගෙන්න යන්නේ. Right? ඒක පොඩි idea එකක් අඳින්න කලින් ගන්න පුළුවන්. See how this comes. G is acting downwards. Now, if I apply an equation like V equals U plus AD upwards, right? V equals U upwards minus G minus GD. That means, right? Shape එක දැන් හොයාගන්න පුළුවන්. This is X gradient minus C V Y. What shape? Y equals minus mx plus c. This is a standard shape. Y equals minus mx plus c. Minus mx plus c again. අපි දන්න curve එක. Right? Minus mx plus c. Minus mx plus c. මේකනේ curve එක. But this is only the half of the motion. Started with u. See what happens now. Use your knowledge. It started with the velocity u, and it decelerates up until the maximum point. So it has reached zero velocity at the maximum point, and after this point, direction of velocity is altered, right? Which means it should be in the negative side. It should be in the negative side. But yet, what about gravitational acceleration? Constant, or is it changing? What about G? What is the magnitude and direction of G for the upward motion? Downwards G. What is the direction and magnitude of G for downward motion? Downwards G. Then in both cases, G remains G. G is constant, right? G is an acceleration. Gradient of a VT graph is acceleration. Then gradient of this graph should be constant, right? With all the verifications, you can complete this up to here. Gradient is constant. Make gradient again back. Gradient constant means angle is a constant, right? ඉතනනම් මේක මෙහෙම එනවා කියලා එහෙම වෙන්නේ නැහැ. Because then gradient changes. එහෙම එනවා මොකක් ගන්නවද? If you plot speed with time, because speed is a scalar, right? This is the only correct curve. Right? Scenario based. Write down below this one with the red pen. Write down below the last one with the red pen. Direction and magnitude of gravitational acceleration. Direction and magnitude of gravitational acceleration. Direction and magnitude of gravitational acceleration. Direction and magnitude of gravitational acceleration remains unchanged throughout the motion. Remains unchanged throughout the motion. Remains unchanged throughout the motion. So gradient remains unchanged. So gradient remains unchanged. Right? Measuring check කරන්නත් පුළුවන්. Gradient is G here. G is the gradient of the graph. Gradient is G. Right? If G is constant, gradient is constant. Right? Now gradient එක වෙනස් වෙන්න බෑ. ඒක තමයි මේ straight line එකක් ආවේ. Right? Gradient එකට වැඩක් නැහැ තියෙන්නේ positive side එකද negative side එකද කියලා. Because what gradient is the angle. Tan value of the angle measured with the horizontal. ඒකට positive ද negative ද කියලා එකක් නැහැ. Right? This is a constant gradient. Doesn't matter whether it's on positive side or negative side. This is a negative constant gradient throughout. හරියටම ඇවිල්ලා තියෙන negative constant gradient. And next point. Sign of velocity changes with the change of direction of motion at the maximum point within brackets since velocity is a vector right. That's it. Then මේ point identify කරගන්න පුළුවන් වෙන්න ඕනේ. For your understanding, මේකේ gradient එක කියලා කියන්නේ if you need gradient is g. In this part also it's same, gradient is g, and this is exactly the maximum point of the graph, right? And this is the initial point, and somewhere here this is the final point, right? And we know that it returns with the same velocity, no? ඒ කියන්නේ මේක අපි check කරලා බලුවොත් මේකට එන්නේ -u කියලා. That's a good result, right? ඒකට එන්නේ -u කියලා. Okay, 10:34. මොකද ගන්න අනිත් ටිකත් ඔය විදිහට මේ ස්ට්‍රීක් එකේම කරලා නවත්තනවද නැත්නම් හෝම්වර්ක් කරනවද? මං කන්ටෙක්ස්ට් එක දෙන්න. මොකද ගන්න හෝම්වර්ක් කරනවද? You have school today? Today නෙමෙයි, tomorrow. Right, මේ මං කන්ටෙක්ස්ට් එක දෙන්නම්. අපි නැත්තුවේ 20 වලින් නේද? For 21, 22, 23, 24 frictional force F equals mu r. Write down this context and you can try the remaining graphs at home, right? And in the class how many graphs we have drawn? 20, 26, 27. Hari. And it has my examples around 30. Hari. Ana examples tune graphs and then okay, for 21, 22, 23, 24 frictional force F equals mu r. Right? Let me write it here. (21, 22, 23, 24) friction F equals mu r, and 25, 26, 27, 28. A and omega centripetal acceleration A equals r omega squared, right? Centripetal acceleration, radius of circle, angular velocity, right? මේ rotational motion equation එක දන්නේ නැත්නම් බෙයා ගන්න. මේ friction නම් දන්නවනේ, frictional force, coefficient of friction, perpendicular reaction. This is centripetal acceleration, centripetal acceleration, right? That is an acceleration. Radius omega, angular velocity. That's all, right? Arun? (29 Lankala). And you can try these scenario based questions at home. 10 questions there. You can try those scenario based ones at home. In these scenario based questions, since I like felt lazy to type this in Word document, I put that on ChatGPT මේකේ part එක cut paste කරලා නැත්නම් අන්තිම ටික වැඩක් නැහැ. හොඳ if you want I can also give ඒ කියන්නේ එයාගේ response එක. type කරන්න කම්මැලි ඉන්න මම මේ ටික දාලා මේ bullets දාලා ගත්තා හදලා ඊට පස්සේ copy කරලා දැම්ම ඔයා ගන්න බැරිලා. හරි. මේ you can practice those 10 questions. මේ ඔයගොල්ලෝ ඒවා use කරලා බලන්න. ඒ කියන්නේ මේ now even in Microsoft Word an AI bot is there as co-pilot. දැන් ඒ වගේ එකක් use කරන්න නැතුව now if you need to create a Word document without opening Word, right? Simply give that command to ChatGPT. ඔයාලට මෙන්න මේ format එකෙන් මේ ටික ඕන කියලා දුන්නා නම් එයා දෙනවා මේ එහෙම එකක් මේ ගත්තම. මට ඕන ටික bullet form එකෙන් number කරලා ඉල්ලලා තියෙනවා. ඒතකොට මට ඉතින් ඒක ආවා. කෙලින්ම copy කරලා දාන්න තියෙනවා. right නැතර word එකේ ඉතින් one by one we have to type it no. right? ඒතර 10ක් type කරනවා කියන්නේ bullets එක ගොඩක් වෙලා යනවනේ. ඒසිනේ. මේ I forgot to erase this last part. මම කෙලින්ම මේකම copy කරලා ගත්තා ඉතින් response එක. okay. Any questions? Then 38. Any questions? Right, listen. Now, this is basically everything that you need to know about graph plotting. Right? But sometimes you will get non-standard curves. Em curves here. Standard curves ibe 25 again, right? So any other curve which is not in the standard list are not standard curves. එහෙම ඒවා අඳින්න පුළුවන්. මම එක example එකක් පෙන්නලා මේක ඉවර ගන්නවා. As an example, say you need to plot something like this. Y equals 5 over x plus 2. Make a standard shape and name. Right? This was not within any standard shapes. Right? But sometimes these kind of graphs can be there. Right? So what we can do is basically we are in that frame of what you have learned. Right? If y and x are numerator and denominator, that is still inverse. Right? That is still inverse, but check its intercepts. Make x 0. When x becomes 0, y is 5 over 2. Which means when x becomes 0, y has a value 5 over 2. Right? And make y 0 and check x value. When y equals 0, 0 into anything is 0. Then x becomes, when y equals 0, 0 is 5 over x plus 2. X plus 2 into 0 is x times 0 කියලා කියන්නේ 0 plus 0 5. ඔන්නෝම එකක් නෙන්නේ. right? මේ තියෙන්නේ මෙහෙම එකක්. මේ තියෙන්නේ and let me write this way. subject කරලා ඉන්නද නැත්නම් කියලා දෙන්න අමාරු. let's subject this. y equals 5 x plus 2 plus multiply this, then x plus 2 equals 5 over y, right? Then x is 5 over y minus 2. Y is when y becomes 0. When y equals 0 ने मम्मी आगे करें. x is මෙතනින් එනවා when y is 0. When y is 0 මේක infinity. Infinity minus 2 කියලා කියන්නේ infinity. So it goes up to infinity. එහෙනම් මේ පැත්ත 5 over 2 but x goes up to infinity. මෙතන විතරක් asymptotic track යනවා. අන්න ඒ වගේ curves තියෙනවා. Not a standard curve but within our frame still we can argue. මෙහෙම curves එනවා, right? Rare, but you will see these curves, see non-standard curves, right? Also in questions. Then in such cases you have to use these options. Then make a tertiary option එකක් tertiary approach එකක්. right? මේ option එක කරලා අද ගන්න පුළුවන්. right? So this basically covered everything. And for these ones මේවා ඉතින් rare occurrences. Papers 20ක් විතර ගත්තා පස්සේ මේවා එකක් විතර තියෙනවා. Something like that. Then we will get to know about these things in the paper class with papers, right? The papers we have the questions, then we'll explain about non-standard ones, right? About 99% of questions, 95% of questions are coming from standard ones. There are still a room for non-standard ones. එහෙම එකක් ආවොත් අපි වෙනම ආගිය කරලා හදන්න ඕනේ. හරි මේ වගේ ඒවත් non-standard මම අර තියපු ඒ වගේ ලියුවේ නැහැ. root x plus 5 වගේ. But still you can argue when මේ මොනවාවත් this basic variation is there. This basic variation is there. Right? When x equals 0, y becomes 5. Right? එතකොට මේක 5 වලින් start කරන්න. But basic variation is there. y equals m root x. Okay. තේරුණාද? අර frame එකේ ඉඳන් අපිට ඕන දෙයක් කරන්න පුළුවන්. ඊට පස්සේ තව පොඩි ආගියුමන්ට් එකක් දාගන්න තියෙනවා. Got the point? හරි? ඒ කියන්නේ non-standard කියලා මේ දැකලා නැති equation එකක් එන්නේ නැහැ. අර වගේම එකක් මේ basic shape එක තියෙනවා නම් that shape is always there in the equation. ඊට පස්සේ intercept එකෙන් තමයි ඔක වෙනස් වෙන්නේ. ඒක ඉතින් x equals 0 y equals 0 කියලා හොයාගන්න පුළුවන්. Okay then. That's enough. Right. See. 10:44. Right. And we have covered everything about graphs, and I will not be doing any comprehensive discussion about graphs in the theory class again, right? And keep your note of this seminar with you that you can use anywhere. I can unit related නෙමෙයිනේ. ඒක වෙනම තියාගත්තත් කමක් නැහැ. Right? You should be able to go back and check it if needed. ඒ කියන්නේ දැන් gradient type එකක් මතක නැත්නම් ගිහිල්ලා බලන්න පුළුවන් වෙන්න ඕන. graph එකේ standard shape එක මතක නැත්නම් even if you get y equals m root x, if you can't memorize y equals m root x, අදින්න බෑනේ. ඒතකොට ඉතින් අරකට ගිහිල්ලා බලන්න වෙනවා. Until you store it in your memory. Right? Okay then if no questions we can wind up. It's 10:44. Right, we'll wind up. Yes, then we'll be meeting on Wednesday and Friday in theory classes and the paper class, right? And we are starting rotational motion here, and in the other class hydrostatics is ongoing, right? Those are the things. Yeah, so if no questions we can wind up, and the next S2A discussion, our next one is also from viscosity, and the one after viscosity will most probably be on friction, that you can stay in touch and join for the past questions, right? Okay then, so practice these things again. I think more than 10 around 18 or 19 questions are remaining, right? Then you can practice those graphs, and around 35 graphs are already completed in the class with the examples and everything, and there are around 19-20 more questions to practice by your own, right? Practice them and check. Okay, then we'll stop. All right then, go safe and stay safe, work hard, right? See you in the class. Good night and goodbye.